The fifth term of an arithmetic sequence is 7, and the eighth is 16. What is the 100th term? Okay, so this kind of question here, the fifth place, 8th place is not very far apart, so sometimes it's nice to actually draw it out here. So this is the first one, 2, 3, 4, 5. So this is unknown 5, and this is 7, 6, 7, 8. And this goes on. The question is, what is U100? So this is U5, 6, 7, 8. This is U8, and this is 16. Now, because this is an arithmetic sequence, we know that we're going to be adding D here. This is plus the difference. We're going to be adding D to go to here. This is another plus D. And then we're going to be adding another D to go to from here to here. We're going to be adding 1, 2, 3 jumps. So we're going to say that U5 plus 3D, this is equals to U8. So U8 is equals to U5 plus 3D. Now U8, we know it's 16 is equals to U5, which is 7 plus 3D. So 3D, just using algebra, is 16 minus 7, which is 9. So D is equals to 3. What is the arithmetic sequence formula? We have UN is equals to U1 plus N minus 1 D. So the 100th term, where N is 100, the 100th term is U1, which we don't know yet, plus N minus 1D. So N here is 100, minus 1. D is 3, as we worked out before here. And so the final challenge is to find U1. Okay, so one way of figuring out U1 is to just concentrate on this first part here, this little subproblem. And what we have is this here is U1, this here is our UN, which in this case N is equals to 5. And in this way, if we set it up this way as a little mini problem, we can solve for UN. So we'll say UN, which is 7, that's UN, is equals to U1, which we don't know, plus N minus 1D. We just said N is 5. And the D is the same as this question here, which happens to be over here, which is 3. So we have U1, this is equals to 7. This is going to be 4 times 3 is 12. And so U1 is equals to 7 minus 12 is negative 5. This is just one way of doing it. So let's just finish off this question here this way. So we're going to plug U1 back into here. So going back to the original question, we have U100 is equals to U1, which is negative 5, plus 100 minus 1 is 99 times 3. And so finally we get the answer. U100 is 292. Okay, let's try the same question one more time just to get the feeling of doing this. So what we have here is the given information, and what can we say? We can say that this here is our UN. So this is UN is equals to U1 plus N minus 1D. Now what happens to be, for this particular problem here, N is 5, so we have 5 minus 1D. And we're just going to say that we don't know what D is yet. So this becomes 7 is equals to U1 plus 4D. As you can think of it, this guy over here, you're going to go 1, 2, 3, 4 jumps. You can use the formula, or you can just manually just add up the D's. Similarly, we have 16. This is the 8th term here is equals to U1. And when you think about it, how many jumps does it take to go from here to here? 1, 2, 3, 4, 5, 6, 7 jumps. So we're going to say plus 7D. And by the way, the number of jumps is simply going to be, from the beginning, is going to be 1 less than the actual N number here. So when we focus on this approach, what we have here is 2 equations, 2 different unknowns, much like systems of equations. We have xy, xy, u1d, u1d. We can solve this. So let's solve this using subtraction. So we're going to treat this like one giant subtraction statement. I'm going to subtract the second equation minus the first equation. So I'm going to subtract backwards. You can subtract or add forward or backward, whatever helps you. So 16 minus 7 is going to be 9. u1 minus u1 disappears. 7d minus 4d is 3d. Divide both sides by 3. We get d is equals to 3. Once we have d is 3, we can use either equation. I'm just going to use equation number 1 to finish off this question here. And what we have is 7 is equals to u1 plus 4d, and d happens to be 3. 4 times 3 is 12. So finally, u1 is equals to 7 minus 12, which is negative 5. So this is another approach to finding the d value and the u1 value, which helps us solve the 100th term in this question.